Welcome to the Wetlands 101 educational series. My name is Jacob McCann. I'm a wetland specialist with the Washington State Department of Ecology. I work out of the Eastern Region office in Spokane, Washington. Today we're going to talk about hydrology, and I'll give some tips and techniques for reviewing wetland reports. As a way of review, remember that hydrology is one of the three parameters that are required to determine if an area contains a wetland. The soils and vegetation requirements are covered in other sections of this program. What is hydrology? It's the water, the driving force in what makes wetlands, well, wetlands. In eastern Washington, we may not have as much precipitation as our western counterparts, but what we do receive via rain and snow winds up in our lakes, rivers, and low-lying areas. In some parts of the state, irrigation projects are bringing water to areas that were previously arid, often forming wetlands. In some ways, finding wetlands can be easier in our region because one can just follow the water. Wetlands need to have water or saturation in the upper 12 inches of the soil in order to be considered wetlands. In the photo on the left, surface water is visible during spring thaw. This is a vernal pool that has surface water well into the growing season most years. In the photo on the right, groundwater is exposed. That isn't a rain puddle, and one can observe both water and saturation. Notice the depleted soils from the pit, another indication that this area is often wet. How much water is enough? Per the U.S. Army Corps of Engineers regional supplements to the wetland delineation manuals for our area, the Western Mountains and Valleys and Coast region and the Arid West region, the upper 12 inches must be inundated or saturated. In the Arid West region, it's important to consider local conditions, as some indicators can be present for a short period after unusually high precipitation events, which is why the growing season is so important. This photo was taken in early April, just at the start of the growing season. Vegetation is beginning to green and the early stages of growth are apparent. Notice the water at the surface. If you were to dig a hole within this area, even where surface water isn't expressing, you would expect to find that water would fill or partially fill the hole that you dug. So we dug this test pit about 30 minutes ago and found water about 8 to 12 inches down. It was saturated right above that. 30 minutes later, we have water basically at the surface. I would say, just a couple inches below that surface layer of duff. So again, we've definitely got a primary indicator of hydrology at this site. The growing season? What is it? The growing season can be variable from year to year. If native plants are beginning to grow or are actively growing, then soil temperatures are warm enough for soil microbes to be active. Soil microbes deplete the oxygen in the upper portions of the soil only when soil temperatures rise sufficiently for the plants to begin to grow. Look for the first buds that begin to swell and open on native trees and shrubs. In eastern Washington, this generally happens a few weeks earlier in the Columbia Basin and southeast parts of the state. While other hydrologic and soil indicators can be used to help identify a wetland, a hydrophytic plant species are also a big clue to help us complete our analysis. That's why we don't recommend conducting delineations when plants aren't actually growing. In frozen or late season drought conditions, it can be nearly impossible to make positive plant ID. When does the growing season start? With the emergence of herbaceous plants from the ground, with appearance of new growth from vegetative crowns in grasses, bulbs, or corms, coleoptile cotyledon emergence from seed, bud burst on woody plants. On the west side, that would be Indian plum, emergence or elongation of leaves of woody plants, or emergence or opening of flowers. Or the growing season has begun in spring and is still in progress when soil temperature measured at the 12-inch depth is 41 degrees Fahrenheit or 5 degrees Celsius or higher. Other vegetative indicators can be seen in these photos. You can see buds beginning to swell on a fringe hawthorn, and you can also see some blooming skunk cabbage, which is an early indicator on the west side and in some areas of the east side that have a little bit more of a moist climate, like the northeast corner of the state. Where do wetlands form? Landscape position is especially important to consider when looking for wetlands. Look in these locations for potential suspicious wetlands. Low spots or depressions, areas that frequently flood, areas that frequently pond, areas adjacent to large water bodies, slopes where water discharges from seeps, or combinations of these features. This graphic depicts a perched water table above an aquitard, a very common condition in our region. This area is connected to a lake greater than 20 acres in size during the early spring, but as the lake level drops, the wetland will not be directly connected with surface waters. However, there will still be a shallow subsurface hydrologic connection between this wetland and the lake. Wetlands associated with lakes are called lacustrine wetlands. This area contains shallow ponding through the growing season most years, but during drought years it may be more transient. Slope wetlands can be some of the most difficult wetlands to locate because they often show up in places where they are not expected. This wetland appears along a road in Moses Lake with no apparent source of hydrology. A leaky stormwater pipe is the likely culprit, but until the source of hydrology is removed, this site will likely remain a wetland. What about drought conditions? This site is a pretty obvious wetland, but while in a normal year this area would be covered in surface water, all that remains are saturated soils and an algal mat. What other indicators could one seek out in this situation? What about a situation that was more subtle? More on that later. What about winter? Wetland delineation should not be conducted in the winter, especially in areas normally covered by snow. However, one can get clues from topography and vegetation to at least note areas that should be visited in the growing season. In this photo we can see a flat depressional pond with some cattails around the edge, so perhaps a wetland when we come back in the spring. What if it's a tougher call? Hydrology indicators are often the most transitory of wetland indicators. Surface water or saturated soils are usually present only during the normal wet portion of the growing season. These may be absent during the dry season or drier than normal years. So clues are what we're talking about. What clues do we need to help us find suspicious wetlands, especially those that are hiding in the landscape? There are two types of hydrological indicators found in the wetland delineation data sheets: primary indicators, of which you only need to find one, and secondary indicators, which you need to find two to make a positive ID for hydrology. Look for the checkboxes for these indicators in the hydrology section of the wetland delineation data sheets. If you find at least one primary indicator, then you have a positive indicator for the presence of wetland hydrology. If you have at least two secondary indicators, then you have a strong probability for the presence of wetland hydrology. This table is taken directly from the Core 2010 Regional Supplement. The page is split between the next two slides to increase the readability. Group A are the strongest indicators, direct observation of water. Group B indicators show strong evidence that surface water has been present. Notice the check mark boxes for primary and secondary. All these indicators are primary except for B9 and B10, which are both secondary in our region. Group C shows evidence that soils have been reduced, and Group D uses evidence of other parameters such as vegetation to support the fact that water has been present on the site. The organization of these four groups, A through D, show the most reliable and defensible indicators to the least reliable ones in descending order of preference. Again, take note of which ones are primary and which ones are secondary. This photo shows inundation of water at the surface during the early spring. It is always important to note the time of year and pay attention to recent storm events. In this location, the water will likely persist within the upper 12 inches of the soil for at least 2 weeks during the growing season. A2 is a high water table. Water filled this hole shortly after it was dug. Note the buttercup in bloom in the photo, indicating that this high water table is present well into the growing season. Be wary of high water tables in the winter or non-growing season, as it may not persist for the 2-week duration during the growing season. A3, saturation. This photo shows saturation in the upper 12 inches of the soil during the growing season. But what if the water's gone? If there's not any water on the surface, then you need to start looking for other indicators. But what if the water is really gone? During a routine on-site determination, you would dig a series of test pits a little over 18 inches deep and look for signs of hydrology. You would also look for hydric soil and hydrophytic vegetation indicators. If you still don't find water, then you go to the next set of secondary indicators, starting with B1, watermarks. I think determining the hydrologic regime is the most fun part of wetland delineation because there are a lot of clues that you can look for, but it can also be the most frustrating if water is not readily evident. B2, sediment deposits. This photo was taken following an early November flood event along the Snoqualmie River system. Note the deposition of sand and silt and the watermark that was left on the tree. This photo could have been used for watermarks B1 as well as for sediment deposits B2. B3, drift deposits. Look for drift debris that was deposited through the landscape. This photo is atypical in that generally you are looking for more subtle evidence of recent drift deposits in the knee-high or below range, but this illustrates the indicator. In the arid west region, this is a secondary indicator that can reflect higher than normal flows and drift material that can persist for many years in an arid climate. B4, algal mat or crust. An algal mat such as this one would take at least 2 weeks to form while the area was inundated during the growing season. B5, iron deposits. You've probably all seen this, a thin or orange-yellow crust or gel of oxidized iron on the soil surface or on objects near the surface. This forms when reduced iron discharges with groundwater and oxidizes when exposed to air. It can form a sheen on the water surface and look like oil. You can tell the difference by touching with a stick, and if it breaks up into blocks, then it is reduced iron. If it swirls, it's oil. B6, surface soil cracks. Surface cracks form from the drying and shrinking of soils. However, these may also occur in temporary ponds that are non-wetlands. You would still need to dig a hole and look for hydric soil indicators. In this photo, hydrophytic vegetation is growing, adding another clue. B7, inundation visible on aerial imagery. The use of aerial photography has become indispensable to land use planners and professionals. Take full advantage of the multiple resources that are immediately available to you when doing your research. Look for photos of the same location taken at different times of the year and in different years for comparison. B8, sparsely vegetated concave surface. In our region, this is more likely to occur at high elevations, but on the west side, this occurs frequently along rocky coastlines. B11, salt crust. Salt crust is a primary indicator in our region. Alkaline wetlands often offer a stark contrast to their surroundings. Generally, they contain hard or brittle deposits of salts formed on the ground surface due to evaporation of saline surface water. This condition is most common in the arid Columbia Basin. B13, aquatic invertebrates. This indicator is occasionally seen within our region. However, there are most often other more prominent primary indicators present in the near vicinity. B9, water-stained leaves. This is a secondary indicator in western Washington because it is considered to be less reliable due to our frequent and heavy rain events. In the arid eastern Washington, it is a primary indicator. B10, drainage patterns. Look for flow patterns visible on the soil surface or eroded into the soil. Low vegetation bent over in the direction of flow, or the absence of leaf litter or small woody debris due to flowing water. Be cautious and aware that other causes may have flattened the grasses, such as wet, heavy snow, high winds, or unusual flooding events. C1, hydrogen sulfide odor. This is the proverbial rotten egg smell. The smell must be found within 12 inches of the soil surface. The sulfide odor comes from a gas produced by soil microbes in response to saturated soils where oxygen, nitrogen, manganese, and iron have been reduced and there is a source of sulfur. This is a primary indicator, but believe me, you will probably already know the area is a wetland. C2, dry season water table. This is a secondary indicator. Water is within 24 inches during the dry season. If it is below 24, it does not necessarily mean that it is not a wetland. Further investigation would be needed. Start by looking harder for other indicators. Try to find a primary indicator if possible, or at least another secondary indicator. It may be necessary to revisit the site. C3, oxidized rhizospheres along living roots. With this indicator, you need to make sure that the rust color is occurring along living roots. Look for orange or red colors along roots. These are called oxidized rhizospheres. C4, presence of reduced iron. The presence of reduced iron in this image indicates that the soil was inundated or saturated for a prolonged period of time, long enough for the soil to develop anaerobic conditions in the upper 12 inches where microbial action reduced the iron. This important process will be discussed in detail in the hydric soils portion. C6, recent iron reduction in tilled soils. Presence of 2% or more redox concentrations in the tilled surface at least within the top 12 inches. Cultivation breaks up or destroys redox features in the plow zone, so the presence of these features indicates that there has been recent soil saturation that has caused the soil to become reduced. C9, saturation visible on aerial imagery. This is only a secondary indicator, but note the stressed plants in the center of the photograph where some of the bare soil show. Be careful using this indicator because the images can be deceiving. D1, stunted or stressed plants. The plants in this agricultural field show clear signs of stress. Water inundated this portion of the field early in the growing season. This does not make it certain that this is a farmed wetland. This could have been an unusually wet spring. More investigation would be required. This is a secondary indicator. D2, geomorphic position. Always note the landscape position for the area you are investigating. This photo shows a low spot in the center of the wide, gradually sloping field. This is a common place to find wetlands in our region. This is a secondary indicator. D3, shallow aquitard. This is a secondary indicator as well. Here we can see water expressing itself along a stream bank following an aquitard. There are other secondary indicators as well. D5, the fact-neutral test, which will be discussed in a presentation that follows. D6, raised ant mounds. These aren't common in our region, but you do see them from time to time. And D7, frost heave hummocks. Again, not often seen in our area. Finally, you review the wetland data sheets to indicate whether you have primary indicators or secondary indicators and are able to positively ID hydrology. This is the portion of a field data sheet for the hydrology section that is included within any delineation report. The wetland hydrology indicators that were just presented are listed on this sheet. There should be one sheet for each data plot recorded for the wetland delineation. Always pay attention to the date that the data was collected. This is critical with regards to the growing season. The box in the middle right-hand side should be the box that is checked either yes or no for the presence of wetland hydrology. A good delineator will check all the boxes that apply to the data plot being recorded. While you only need one check for any of the primary indicators listed, it is common to find more than one primary and sometimes two or more secondary indicators at any one data point sampling location. More information is better. Quick review. So, when you're reviewing data sheets for wetland hydrology, pay close attention to the date on which the data was collected and look at the checks for the hydrological indicators. Always look for consistency with regard to recording of the data collected and the final wetland or non-wetland determination being made. Remember, wetland hydrology needs to be present in the upper 12 inches of soil for at least 2 weeks during the growing season. landscape position, and adjacence to existing water bodies are important considerations. Look for clues in the form of hydrologic indicators, and you need 1 primary or 2 secondary indicators. Thanks for taking the time out of your day to watch this video. We hope you found some information that will be useful for you in your work. Please don't hesitate to get in touch if you have any questions, and check out the other videos in this web series.